Welcome to solving equations that have three unknowns. We're first going to look at just an equation that has three unknowns and whether an ordered pair would solve that equation. Then we're going to look at solving systems of equations, three equations and three unknowns. And when we say solving them, we want to see if we can find the ordered pair that simultaneously solves the three equations. In other words, the point that solves all three equations at the same time. Sometimes it won't happen if we have parallel planes. If the plane is the same, then we'd have an infinite number of solutions. But if the planes intersect each other in such a way, there will be one point where where a ordered pair will solve all three equations at the same time. So we're going to start with this first problem where we really are just going to put the different coordinate values into the equation just to make sure that it truly does solve the equations. Then we're going to work on some of the problems where we have three equations and three unknowns and trying to see if we can find a solution. So we're going to see if 2, 1 minus 4 solves the equation 2x minus 3y plus 2z equaling negative 7. So in for x, I'm going to put a 2. So 2 times 2 minus, then 3 times y, where the value of y is 1, plus 2 times z, whose value is negative 4. Does that, in fact, equal minus 7? That's what we're trying to see. If it does, then 2, 1 minus 4 solves this equation in three unknowns. So we look at 4 minus 3 minus 8. Does that equal negative 7? And in fact, it does. Negative 7 does equal negative 7. Therefore, 2, 1 minus 4 solves this equation in three unknowns. Now I want to solve these three different equations for the x, y, and z that would solve all of these at the same time simultaneously. Now my methodology in doing this, because when you do three equations, three unknowns, you can kind of get lost in the work. So I always suggest to actually label as much as you can as you're doing this. So I'm going to call this equation 1, and I'll label it equation 1, and equation 2, and equation 3. Now I want to strategize. I'm going to try to get rid of one of the variables. I have to decide at the very start what is the first variable I want to eliminate. So I'm going to use the elimination method. So I look at my x's. I see that I have an x, a 2x, and an x. None of those equations, when I add them together, would eliminate the x variable. In other words, if I took equation 1 and equation 2 and added them together, I'd get a 3x. If I look at the y's, however, I see that if I took equation 1 and equation 2 and added them together, I would eliminate y, because one of the y's is positive, and in fact it's a 1y rather, and a negative 1y on equation 2. That I don't even have to multiply one of the equations by a number. When I add them, the y's will eliminate. And since one of the y's is a negative 1y, it makes it very easy for me to take equation 2 and equation 3 to eliminate the y's. So what do I mean by all that? Well, I've now determined that the y's look pretty easy to get rid of. So what I'm going to do is I'm going to take equation 1 and equation 2 and eliminate y. If I take equation 1 and equation 2 on my first round of elimination, equation 3 must be one of my equations to eliminate y again. So I'll take equation 1 and equation 2, and all I have to do is just add them together, and y will be eliminated just because the way that those equations are. When I add them together, I get x plus 2x gives me 3x, plus y minus y. That's exactly how I determined I wanted to get rid of my y's. And then 2z minus a z gives me a plus z equals 1. That gives me a new equation in just two unknowns, and I'm going to call that equation 4. So now I have an equation with two unknowns. So what I want to do is try to take my equation 3 and one of the first two equations and eliminate y. So I get another equation that has only two variables, and those variables have to be x and z. So I'm going to look at equation, as I said, since I used equation 1 and equation 2 in my first round of elimination, I must use equation 3. So I'm going to look at equation 3, and I determine which of the equations, equations 1 and 2, I need to use to easily get rid of y. Since y was the variable I had determined I wanted to get rid of first, I must continue with getting rid of y. So in looking at these, my y is 2y. Equation 2 is negative 1y. Well, if I multiply equation 2 by 2, I would get a negative 2y. And watch what would happen. If I add these two equations up after I multiply equation 2 by the number 2, I get 4x minus 2y. 2 times this minus z is negative 2z. And 2 times 1 is 2. That's why I can multiply the whole equation by 2, is because it is an equation. So what I do to one side, I do to the other. So now I'm going to take equation 3 plus this 2 times equation 2 and add them together. When I do this, I'm going to get a new equation, equation 5, and this equation 2 will only have x's and z's. So I take 4x plus x to give 5x. The y is eliminated because we made that happen. And 3z minus 2z gives me a positive 1z, or just z. It's an understood 1 in front of the variable. 1 plus 2 gives me 3. Now I have these two new equations, equation 4 and equation 5. I now have two equations and two unknowns, and I can use the elimination method to find one or the other variable. And I determine which variable would be the easiest to get rid of or to eliminate. Well, I don't want to get rid of the x's if I have to, because this has a coefficient of 5, and in equation 4 it has a coefficient of 3. Not that that's too terribly difficult, but when I look at z, I have one z and another one z. So that's probably the easiest one to get rid of. So when I add equation 4 and 5 together, the z's will eliminate. So I'm going to take negative 1 and I'm going to multiply equation 4 by negative 1. So 3x times negative 1 is negative 3x. That plus z times a negative 1 is negative z. And on the right-hand side, 1 times negative 1, of course, gives us negative 1. I'm going to add that to equation 5. Equation 5 just above is 5x plus z equal 3. When I add these two equations up, my z's eliminate, and I have 2x equals 2. Or I have now solved for x, which is 1. That means x equaling 1 is a variable that solves all three equations simultaneously. So now I need to find out what my other variables are. Well, now this is where you kind of backtrack. I can put this x equal 1 either in equation 4 or in equation 5 in order to find z. So I'm going to use equation 3. I'm going to use equation 4. So I'm going to put x equal 1 into equation 4. When I do that, I would have 3 times that x value, which is 1, plus z equaling 1. And now I just solved my equation for z. So I would subtract 3 from both sides, and I'd have z equal a minus 2. Now I have two of my variables that will solve the three equations and in three unknowns. I now have two of the variables. So I've got to go back into one of the original three. I'll input the x and the z value and solve for y. So I'm going to choose to do equation 1. X is 1 plus y, that's what I'm solving for, plus 2 times z, and that's supposed to equal 0. So if I do this, I get 1 plus y minus 4 equals 0, y minus 3 equals 0 or y equal 3. So I now have the ordered pair that solves these three equations simultaneously. The ordered pair is 1, 3, minus 2. And there's my answer. Now do note, you can always check your answer because you can make little small math errors, still get an answer and be incorrect. I highly suggest that you put 1, 3, and minus 2 into all three equations and make sure that your answer is correct.